How will the universe end? It's a question as vast as the cosmos itself. Imagine a future trillions of years from now. The stars have burned out, the galaxies have drifted apart, and the universe, cold, dark, and empty, reaches its final fate. But how? Will it collapse, rip apart, or fade into eternal silence? Today, we explore the 4 most terrifying ways the universe could end, and trust me, the last one is more horrifying than sci-fi movies. Let's start with one of the most widely accepted endings based on current science: the Big Freeze. As you all know, the universe is expanding at unimaginable speed, thanks to something we call dark energy. We don't fully understand, but it's pushing our galaxies away from each other faster and faster. And at this rate, other galaxies will be so far away from us that we cannot reach them even at the light speed. And after billions of years, galaxies will drift so far apart that their light won't be able to reach us, and our night sky will be completely dark and empty, as all stars will burn out and no new stars will form. Black holes will dominate for a while, but even they won't last forever. They will eventually evaporate via Hawking radiation over trillions of years. Eventually, the cosmos reaches absolute zero. No heat, no light, no motion. But quantum fluctuations might still occur. But for all practical purposes, the universe becomes a lifeless, frozen wasteland. No explosions, no drama, just an eternal, silent end of the universe. But what if the expansion didn't last forever? Enter the Big Crunch, a scenario where the universe doesn't freeze, it collapses. This idea is based on gravity eventually overpowering dark energy. If someday the expansion slows and reverses, everything starts to fall back in on itself. Imagine galaxies accelerate toward each other at incredible speed, and solar systems are crashing and temperature is rising to billions of trillions degrees Celsius. The entire universe, all of space-time, galaxies, stars, black holes, nebulas, everything in the universe eventually collapsing into an unimaginably dense point called singularity. Some scientists speculate that this could lead to a new universe, in a cycle of eternal rebirth. Big Bang happened, universe created, expansion of the universe, then it collapsed, and repeat it for eternity. It's a powerful reminder that shows everything that grows will fall one day. But if that wasn't bleak enough, there's one scenario that stands out as the most unpredictable, and arguably the most terrifying, way the universe could end: vacuum decay. In the strange world of quantum physics, our universe might not be in its most stable state. It could be living in what's called a false vacuum, a kind of temporary energy minimum that only appears stable. Somewhere out there, a more stable state, a true vacuum, might exist. And if, by pure quantum chance or a high-energy event, a transition were triggered, it would create a bubble of this true vacuum. The moment this bubble forms, it begins to expand at the speed of light. It wouldn't just destroy stars or galaxies, it would erase the very fabric of reality. Inside this expanding bubble, the laws of physics would be completely different. Matter as we know it would disintegrate, atoms would no longer hold together, and everything, planets, light, even the structure of space-time, would cease to exist. And the truly chilling part? We'd never know it happened. Because this bubble travels at light speed, there'd be no warning, no flash in the sky, no time to react. One moment, everything's fine. The next, nothing. While scientists believe this isn't likely to occur anytime soon, if at all, it remains a real possibility hidden in the equations of particle physics. Now, let's delve deeper into what many scientists consider the most likely fate of the cosmos: heat death, the chilling conclusion to the Big Freeze. In this scenario, the universe doesn't end with a bang or a collapse, but with a slow, inevitable slide into maximum entropy, a state of total disorder and uniformity where no useful energy remains. Entropy, in simple terms, is the measure of chaos, and the universe has been marching toward higher entropy since the moment of the Big Bang. Over time, stars burn out, galaxies stop forming, matter decays into ever simpler particles. Even black holes, the most stubborn structures in existence, will eventually evaporate through a process called Hawking radiation, but it will take unimaginable spans of time, trillions upon trillions of years. When the last black hole fades, what's left behind is a dark, cold, and almost completely empty cosmos, a thin, silent fog of particles drifting through an endless void. No stars, no planets, no light, and with all energy evenly spread out, no new structures can form, no processes can occur, no clocks can tick. Time, in any meaningful sense, stops. This isn't a dramatic cosmic finale. It's more like a slow, invisible erosion. A universe that once blazed with galaxies and life, reduced to a still, frozen whisper. The end not by fire, nor by ice, but by sheer, unrelenting emptiness. The death of the universe, not with a scream, but with a sigh. So how will the universe end? Will it freeze into eternal stillness? Will it collapse inward, crushed by its own gravity? Will it simply fade? Or will it vanish in the blink of an eye, swallowed by a bubble of new physics we never saw coming? Maybe we'll never know. Maybe the answer lies so far in the future, it's beyond the reach of even our boldest imagination. But asking the question, wondering, exploring, searching, brings us closer to understanding not just the fate of the cosmos, but what it means to be here, now, in this fleeting moment. If you found this journey through deep time and distant futures as mind-bending as we did, make sure to like the video, subscribe for more explorations into the unknown, and hit the bell icon so you never miss a cosmic mystery.